Broadcasting from Boston, Massachusetts, the Smart Cities podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.
Welcome to the ARC Advisory Group Smart City Viewpoints podcast. I'm Jim Frazer, Vice President of Smart Cities here at ARC Group. And today we'll be talking about the top 12 reasons to use systems engineering for your smart city project. In today's discussion, we'll be examining 5 different aspects of systems engineering. First, we'll examine the systems engineering process. Number 2, we'll discuss technical standards and how they impact the development, the delivery, commissioning, and ultimately the retirement of the project. We'll discuss and describe challenges to the process and how to surmount and overcome them. We'll plunge into a number of real-world applications. And then finally, we'll wind up the discussion today by reviewing the top 12 reasons to use SEP for your smart city project. So what really is systems engineering and the systems engineering process? Well, SEP is an interdisciplinary approach and a means to really enable successful systems. It focuses first on defining customer or end user needs, and then in later steps, those needs are refined into requirements, the required functionality needed for the project. All along the way, you're required to document your requirements so you can proceed with design synthesis and system validation. Now, there are a variety of different ways to describe and to graphically portray the systems engineering process, but one of the most popular is the systems engineering V diagram, which represents the entire life cycle of any project or system. And whether the system being deployed consists of a CAD system for a transit agency, or even a traffic management center, or body cameras for the police, all systems will follow some variation of that life cycle. So what's a user need? Well, a user need is generated through a very robust examination of needs from all the stakeholder communities that may have an interest in this envisioned project. So, stakeholder communities, some of them are well known. You have elected officials, city management, police and fire, the public works department, but it's very important to expand well beyond that to perhaps the downtown business community, adjacent public agencies, maybe the parent-teacher association if there's a safe route to school walking path for children going to school. Once you extract these user needs through, and frankly, they should be a long-form narrative from multiple individuals within each stakeholder community, you would then embark on a path of refining them and seeing which ones have consensus across the variety of stakeholder groups. That's a fairly lengthy and exhaustive process. But once you have those consensus-based user needs in a textual format, you can then move into the second step, which is refining them into measurable functional requirements. So in that step, you would take those user needs and refine them into measurable requirements with numbers, with specificity of engineering units, and legal ranges for each object in each of those requirements. And then lastly, is the test planning. Test planning and testing doesn't happen just at the end. It happens throughout the entire life cycle. So you might test subsystems at the factory. You might test, it's encouraged that you would test assemblages, so smaller aggregations of technology, and then you move on to finally testing the entire project all together. The goal of testing is to confirm that you're satisfying those user needs and that no other needs or requirements have woven their way into the project. So a key to success of SEP is the identification of needs and functional requirements. So when developing your system, the focus really needs to be on exactly what the system needs to do and not how the system will do it. Every user need should have at least one requirement, and every requirement should be directly connectable or traceable back to at least one underlying foundational user need. So in a structured SEP process, a traceability matrix is used to document and verify these critical relationships. This matrix may be maintained directly in a database or even in a spreadsheet for smaller projects, or in more sophisticated and larger applications, it can be generated and maintained with a requirements management tool. Regardless of what approach you take, this matrix provides backwards and forwards traceability between stakeholder needs and other potential requirement sources, system requirements, and the design, implementation, verification, test cases. So next, let's look at the value of technical standards. The standards are primarily used in the design stage of the systems engineering process after the higher level of activities, such as that user needs assessment, the concept that comprise the concept of operations. During this detailed design phase, specific messages, data elements, communication profiles, and design options are discussed and defined. It's important to also remember that standards can provide critical user operational needs and interface requirements during this project definition phase. So that's a quick overview of the systems engineering process. So let's move on to challenges that often occur when using this approach. Well, technical challenges are one. Technical challenges are more easily overcomable than institutional challenges, and often additional training can minimize or even alleviate these issues. So some technical challenges that you might find are gaps in existing skills, inconsistent industry support for standards, whether they be communication standards or others, the technical challenge of actual evaluating conformance to particular standards, the paradigm shift from non-standards-based approaches to standards-based approaches. Now, institutional challenges often take far more time to overcome, though perhaps employee turnover with new management that may be open to new ideas may move that ahead quite a bit faster. Or even the emergence of an internal embedded champion to get buy-in from the decision makers. Institutional challenges can include not everyone in an agency might be willing to articulate their needs, not only in the agency, but not everyone in the community. So it really takes a creative process, an engaging process, and a substantial outreach. Of course, within institutions, particularly if they've been in existence for a long time, like many of our public agencies, there's often an internal resistance to change, particularly when long-term legacy approaches are embedded within the culture of the organization. Then there's also the situation of regional integration. No longer are applications siloed, both either within a city or public agency, but they're also not siloed across adjacent geographical agencies. So that's something to certainly think about. Real-world lessons. Functional integration is one real-world lesson we'll talk about. Functional integration really is a subset of the integration process or systems integration process. During this, systems components are assembled into a working system and verified to ensure that they fulfill all of those system requirements, those requirements that are dependent upon the originally defined consensus-based user needs. Using a puzzle analogy, assembling a puzzle is helpful for this step. The challenge in any smart city project puzzle is that not all the pieces are available at the same time, and some will not fit together particularly well at first, and there will be pressure to change some of the pieces after having already assembled them. But you don't want to change them because, once again, they're dependent upon those originally defined user needs that have been brought in under that umbrella of consensus. Now, jurisdictional integration is another lesson that we can learn from the real world. The intent of jurisdictional integration is to integrate processes that allow seamless coordination among jurisdictions. Although these jurisdictions, as we all know, continue to operate as separate geographical, functional, and political entities. Technical integration issues relating to jurisdictional considerations involve not only design, but also implementation of particular solutions, as well as what really needs to be a well-coordinated effort across regional entities. So while jurisdictional issues often have organizational and coordination implications, these issues often interact with and affect technical system integration issues as well. Therefore, organization and coordination issues must be considered in parallel with that technical integration process. And then lastly, our last real-world lesson is legacy systems. One of the largest, probably the largest, and very common hurdle when developing smart city applications is to make them compatible with existing systems already deployed. There are several important factors that must be considered when integrating new, interoperable, non-siloed systems with existing ones. These can have significant impacts on system costs and deployment schedules, as well as operability issues and interoperability issues. These issues include integrating with existing legacy systems to save costs associated with implementing the new system, as well as complying with standards wherever possible. So now we've established a foundational knowledge of SEP. We've discussed some of the deployment issues. So let's just quickly review the top 12 reasons to use systems engineering for your smart city project. Well, SEP does offer a wide variety of benefits to smart city project stakeholders. These include helping define the scope of smart city projects. Today in the world of the smart city, there's a plethora of vendors. They all have some very dramatic tools that have dramatic impacts to applications. There's a wide variety of simply superb solutions. However, there is a requirement as a public agency leader to really define what you're going to do first and how impactful is it going to be. So SEP, by reaching out and defining those consensus-based user needs, really helps define the scope of smart city projects in an unambiguous way. Reason number 2 is that SEP drives a much higher level of stakeholder participation. The anecdote I like to use here is no one wants to build a bridge and have the bicycle community participate late in the process and say, hey, you forgot to include a bicycle lane on the bridge, and now it's too late. So by having stakeholder participation, you alleviate some of those type of issues. And actually, as we all know, problems are much less costly to solve and have a much less negative impact on the project schedule when they're uncovered earlier in the project process. Number 3 is that the systems engineering process increases the likelihood that this new smart city system actually meets user expectations. No one wants to build a project that only satisfies some of those consensus-based user needs, and as well as perhaps including some costly features that are not supported by those underlying user needs. Number 4 is that systems engineering generates much better smart city documentation. You have, at a minimum, your documented user needs, all the underlying narratives to those user needs. You have your refined, measurable functional requirements, and you should have a robust set of test plans, from device to subsystem to system to full commissioning documentation, as well as the related test documentation. Number 5 is that SEP reduces the risk of cost and schedule overruns. Once again, by defining and uncovering issues earlier in the process, cost is minimized, and the schedule overruns are minimized as well. Number 6, SEP minimizes defects in accepted products, because if you do define a test plan early for your device, you can test at the factory and identify those before a full production run has occurred, and certainly before the products have arrived on site. Number 7 is that SEP drives out risk and drives more predictable outcomes to your project. Number 8, SEP provides a framework and a process to verify that the smart city system meets those documented user needs. So it's a replicable framework that, once it's employed on one project and the culture of your organization adopts it, it can easily be used on projects of all sizes, from small to large, as you move forward in your smart city planning. Number 9, SEP provides more adaptable, more resilient smart city systems. With that support of a standards-based approach, it allows plug-and-play interoperability and the reduction of silos in your smart city projects, so that each successive project could in fact build upon previous projects. Number 10 is that your test planning verifies system functionality, so that all those measurable requirements are in fact confirmed to be delivered from your vendor. Number 11, SEP allows a higher level of reuse from the original smart city project to projects in the future. Since it's all documented, this now becomes a cut and paste module that can be used in many other sites across your public agency, in adjacent public agencies, or across the nation and the world. And then number 12, SEP is required for access to federal funding. The US DOT has Federal Rule 940 in the Federal Register that requires an SEP process for any of your transportation projects. SEP is also used by the Department of Energy for many smart grid projects. It's been used by NASA for their systems, and it's a well-known philosophy. So that's a quick overview of the importance, the value of systems engineering, and 12 reasons why it's very applicable to your smart city project. So thank you for tuning in to this edition of the Smart City Viewpoints podcast by ARC Advisory Group. And we look forward to you listening to this one as well as many of our podcasts. Thank you very much, and we'll be talking to you soon. Take care. Bye-bye.
Broadcasting from Boston, Massachusetts, the Smart Cities podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.